All right, so now we look at equations that have a bunch of fractions, maybe more than one on each side of the equal sign, but it's no reason to freak out because we're going to do just like we did in radical expressions. We're going to take an algebra 2 problem and turn it into an algebra 1 really easy problem. So follow these steps, pause for a moment, fill in the blanks, and then let's talk about it. First step, factor all denominators if necessary. Well, I have x, I have 2, and I have x. There's nothing to factor there. There's nothing extra going on with those, so we're good. Step 1's done. Nice and easy. Step 2, we want to give all terms a common denominator. So let's start off with a lot of what we did when we were adding and subtracting rational expressions. We want to find the LCD. Well, I need to have a factor of 2, and I need to have a factor of x. So 2x is going to be my LCD. Okay? So now we need to give each part of my fraction that common denominator. This first fraction is missing a 2. The second fraction is missing an x. And the third fraction is missing a 2. Go ahead and multiply and rewrite it out so that way we can identify the excluded values in step 3. 5 times x gives us 5x. Negative 11 times 2 will give us negative 22 over 2x. So now, step 3, identify the excluded values. This is one of the first things we did in section 6-1, was we want to know what's going to make the denominator 0. So essentially, it's like trying to solve for your denominator. We want to say, what is going to make the denominator, 2x, equal to 0? Because that makes my whole equation undefined and no good values for x. So we're going to say, what can x absolutely not equal? Well, let's solve. What can we plug in here? We can plug in a 0, and that will make the whole thing 0. So we say that x cannot equal 0. That's my excluded value. Okay? I'm actually going to go ahead and write that up here off to the side where I have a little bit more room. You guys have more room on your page. I'm going to erase this for right now. And I'm going to move on to step 4. Step 4 is multiplying both sides by the denominator. Well, my denominator is 2x, so I'm just going to write parentheses around the entire equation. And I'm going to multiply by 2x. And notice that's in the numerator, because this 2x is going to go to each of these fractions. And when that happens, I'm going to have a 2x here, here, and here. And what happens? 2x cancels, 2x cancels, and 2x cancels. Each one of those fractions, independently, they're all surrounded by multiplication, so those can all cancel out. What am I left with? Just the 8, the 5x, and the negative 22. Right? The only things I'm left with are my numerator. Now we've turned that algebra 2 problem into an algebra 1 problem. Solve for x. Start by moving the 8 to the other side. Divide both sides by 5, and we get x equals negative 6. Our last step is to check if our solution is an excluded value. So what we're doing is we are checking back up with step 3. Is negative 6 going to be something that's going to make this equation undefined? Absolutely not. We are totally fine here. So it's not 0, so we can get through this problem without any issues at all. Okay? Pause, rewind if you need to. Make sure you've got all those steps down in front of you. Keep referencing them back as we go through the next examples. Okay. Example number 6, 1 over x squared minus x equals 1 over x minus 1. So step 1, factor. This denominator we actually can factor. There is a common factor of x in each of these two terms. So when I factor an x out of x squared, I'm left with x. When I factor an x out of negative x, I'm left with just negative 1. So that's going to give me my LCD of x times x minus 1. Because this fraction already has the x minus 1, I have an x minus 1 here. I still need that x. Okay? So there's my LCD, and I'll look at my excluded values. What can I plug in for x that's going to make my LCD 0? Well, with this first one, we know that x cannot equal 0. And then what can I plug in for this x? 1 minus 1 will give me 0, so x cannot equal 1. Both of those are my excluded values. So if either of those show up, I'm in trouble, and I'm not going to be able to use the solution I found as a solution. Now, let's go ahead and make sure that each of my fractions have that denominator. Well, my first one's already set, x times x minus 1. That means this one just needs an x. Whenever I multiply one side, or my denominator, by that value, I multiply my numerator by that as well. So I'm going to rewrite my equation now with what I have. 1 over x times x minus 1 equals x over x times x minus 1. And now we get to move on to that fun step of multiplying by the denominator. Both sides by our denominator. Point here is that everything is going to cancel out. And I'm left with just my numerators. And there I have 1 equals x. I'm done. Take a look. The only things that were left were 1 and x. That was it. But there's a fly in the ointment. There's a problem, right? X equals 1. That was one of my excluded values. So what does that mean? No solutions. We always have to check, because we're doing this kind of shortcut here by multiplying by the denominators that could end up erroneously giving us a solution that is invalid. Okay? We'll talk about more what these mean when we're actually graphing. Okay? So, pause, rewind if you need to. Let's take a look at the next example. Ugh. Another one that looks really gross, right? Not to worry. We'll take a look. First of all, can I factor anything out of my denominators? There's nothing really in common between each of the individual terms. So let's go ahead and jump to my LCD. Step 2. Each of them has an m squared, and the first two have that 4. So we need to make sure that every one of these has a 4m squared. Well, which one needs it? Just the last one needs the 4. Multiply both top and bottom by 4. Okay? What can we plug in for 4 in the to make this excluded? Again, we can plug in 0. 0 squared is 0, and 0 times 4 is 0. So we say that m absolutely, definitely cannot equal 0. Okay? So we're ready to go. We're ready to go ahead and multiply this. 4 times 1, I'm even just going to rewrite this. 4 times 1 is 4. Now I can move into that step where I multiply everything by the denominator. All of my denominators go away, and I'm left with just my numerators. 1 plus m minus 5 equals 4. Go ahead and combine the like terms on the left side. 1 and negative 5 combined together to give me negative 4. Add the 4 to both sides. And we have m equals 8. That was not one of my excluded values, so we say it is okay. No problems there at all. Okay, last two examples. You're going to have to watch one more try. The video is going to be called Last Two Examples.